The quick and easy way to use the calculator. This is the method I normally use. If the calculator proves the object to be abnormal, I will take more accurate measurements using Photoshop. The easiest way is to show you an example. I videoed the object behaving strangely. When first observed, it travelled slowly to this position where it remained for approximately 2 minutes. In 2 seconds, it accelerated from a stationary position to its last visible location. Using a metric ruler, I measured the object's initial and final size, the distance it travelled and the width of the video, all in millimetres, and entered them into the calculator. Enter the object size, start and finish. Enter the distance travelled. Enter the time taken. Enter the size of the lens. Enter the width of the video. Enter the width of the camera sensor. Press the Remember Setting button to remember the camera setting. The calculator will analyse the data, and the analysis shows it is no ordinary craft. The G-forces are too high for normal aircraft pilots. The only earthly craft it could be is the TR-3B. Testing the accuracy of the calculator with a known object. For the test, I wanted to get the measurements more accurate, so I entered the video pixel width into the calculator, 1920. This gave me 46.3. I captured a still image using the free program SM Player and opened it in Photoshop. I pressed image size and entered 46.3 into the resolution box and changed units to pixels centimetre. I also changed the width and height to millimetres. This gave me the width of the photo, 414.69. I zoomed in and measured the length of the plane using the ruler tool. This gave me 16.5 millimetres. Using the ruler tool and 2 stills from the video, layered in Photoshop, and a portion cut out to reveal the layer below, I measured the distance travelled, which was 246 millimetres. The plane was an Airbus A320 with a length of 37.5 metres. I wanted a direct result, so I entered it into the TR-3B box, which gave me a speed of 866 kilometers per hour, 538 miles per hour. Its distance was 16.3 kilometers, 10.133 miles. I had tracked the plane with flight radar. The distance accuracy is about 1%, but in my experience, the calculator is more accurate than my attempts of plotting the plane. The speed accuracy is less than 1% at about 0.45%, which is very accurate. This last example is a bit of an experiment. One of the reasons I selected it is because the object's start size is much smaller than its finish size. I researched the camera used and the lens focal length. The TV presenter thought this object was a drone. The calculator proves this was no drone. It was going at a speed of 2323 kilometers per hour, 1444 miles per hour, and it was too fast to be an ordinary aircraft. So I know the lens focal length of a camcorder at a mid-zoom setting. I compared it with a fixed lens. The camera on the table is infrared only. I use it alongside an ordinary camera to test for the visibility of a craft to the human eyesight. I use SM Player for a video playback. Press S to take screen snapshots, easily go to a frame backwards or forwards, and the playback speed can go down to 10%. For time-lapse, I use VW64. It easily plays back stills as a video at near full screen and at any FPS.